Before we look at the earthworks operations, we first need to familiarise ourselves with the tools we will use. In the case of earthworks, the tools are mainly big machines, which we call plant. The big machines used in earthworks and pavement construction is called plant. One machine is called a piece of plant, and multiple machines are just called plant, not plants, as which would seem logical. Plant may be used in a variety of ways. Some plants, such as excavators and bulldozers, are designed to cut and move material. Other pieces of plant, such as trucks, transport it. Rollers or compactors are plant that are designed to compact the soil, while graders are designed to trim and shape the soil surface. Some plants, such as scrapers, can do more than one operation. We also have water carts to wet the soil, to adjust the water content, or reduce dust nuisance. These water carts are trucks with a water tank and a spray system fitted to them. When we need to dry the soil, we use tractors with discs, which are used to turn the surface soil to allow it to dry better. Excavators are primarily designed to excavate soil. They are equipped with a digging bucket at the end of the arm, which in turn is connected to a boom that is connected to the excavator body. Each of these components is controlled by hydraulic rams, or cylinders, which extend and contract to move the component. The operator sits in the cab in the front of the engine. The operator sits in a cab beside the engine. The cab is located to provide a good view in front of the excavator, but note that the operator's visibility is blocked by the boom on one side and the engine at the back, which is a significant safety risk. The top sections of the excavator can swivel on the tracks, so the tracks stay in one place while the rest of the excavator rotates. This allows an excavator to excavate, turn, and unload onto a truck without having to move the tracks. This allows it to load soil much faster. The downside of this is that the tracks have to be powered by a hydraulic system, as the mechanical coupling from the engine to the tracks would be too complicated. This means that excavators have less tractive power than similar sized plant. They have enough power to move themselves around, but are not really suitable for towing other plant. Most excavators are mounted on tracks to allow them to operate in soft and rough ground conditions. However, there are versions that are mounted on wheels, which are mainly used when the excavator has to work on a public road. The disadvantages of tracks are that they are more expensive than wheels to both buy and maintain. Also, tracks are slower than wheels. This low speed and relatively small volume that can be held in the bucket means that excavators are not really suitable for transporting materials more than very short distances. Loaders are used to load loose materials onto trucks or to transport loose materials or aggregates, materials or tools, short distances. In other words, they're like a motorized wheelbarrow. They are not designed for excavation of soil masses or for excavating below the ground. They are only able to pick up loose material from the ground. This material may be soil that has been loosened up by excavators or rock that has been ripped by bulldozers, and the loader usually loads this material onto trucks. Loaders consist of a wheeled body with a bucket in the front. The bucket is mounted differently from an excavator, so loaders tip when loading, while excavators tip down. Tipping up when loading allows them to better load loose materials, and having a larger bucket means they can load more than a similar sized excavator. Being mounted on wheels allows them to move faster, and they are often articulated so they can turn tighter. These features enable loaders to load trucks faster than other plant. Trucks are used to haul soil in an earthworks operation. They normally have wheels, which mean they can move faster than plant with tracks. They also have a relatively large capacity, so they are very effective at moving soil longer distances. However, they need to be loaded by an excavator, which means they are not as efficient as scrapers or bulldozers if the soil only needs to be moved a short distance. There are basically two main types of trucks used on a civil construction site. On-highway trucks, as shown to the right, are designed to run on the road which means they are not loaded above the allowable highway loading limit, and they are designed to operate efficiently at road speeds. They have a conventional rigid truck chassis and a diesel engine. Moxies, also known as off-highway trucks or dump trucks, as shown to the left, are designed to be specialized earth-moving equipment. They can be loaded over the allowable highway loading limit and so have more capacity. However, they cannot run on public roads as they will break them up. They are designed to be able to haul soil over rough, steep and muddy ground that an on-highway truck would not be able to move on. For example, the suspension system of a Moxie is stronger and the chassis is more robust and higher off the ground to provide more clearance so the truck can move across more rugged terrain. Many Moxies are articulated, which means they are steered through a hydraulic system that turns the whole cab rather than just the front wheels, as is the case with an on-highway truck. This provides the Moxie with a very tight turning circle, allowing it to maneuver in a very small area. The articulated connection often has an oscillating ring that allows the cab and rear part of the truck to twist in relation to each other. This means the truck has all wheels on the ground, even in very rough terrain. There are usually 4 or 6 wheel drive with the engine and gearing designed to provide more power at lower speeds, so that the Moxie is a little bit slower with a top speed of around 50 to 60 kilometers an hour compared to the 90 to 100 kilometers an hour for an on-highway truck. However, this design means that the Moxie is able to climb steeper slopes. A Moxie can get up to a 35-degree slope, 35-degree slope, which is 1 vertical to 3 horizontal, while an on-highway truck can only climb a 20% or 1 in 5 slope for a short distance, and really only works well in slopes up to 1 in 8. Trucks used in earth moving are dump trucks, which means that the tray can be tipped using hydraulic rams next to the cab. When the tray is raised, the soil is dumped out the back. The dumping of soil is usually done while the truck is stopped, in which case you end up with a pile of soil that needs to be spread by other plants such as a bulldozer. Moxies are designed to allow quicker loading and dumping. Therefore, they have a wider tray to allow a bigger target for the excavator to tip into. The tray bottom is often V-shaped to reduce the shock of loading and to center the load. Also, the tray is shaped upwards to remove the need for a tailgate, and the hoist on the Moxies has a higher hydraulic pressures so it can be raised and lowered faster, so allowing quicker dumping. So Moxies are optimized for earth moving, but they're only really economical on large earth moving projects as they are expensive. They need to be transported to site, and they are only really suitable for earth moving. On-highway trucks are a little bit less efficient at earth moving, but they can be used for other functions such as transporting plant and importing fill or aggregate. It also means they are easily moved to site, and so their use is flexible. There are companies that specialize in providing trucks when required, and this gives the project manager the ability to vary the number of trucks on site according to the amount of earth being moved on that particular day. Let's look at bulldozers. The main activity for a bulldozer is to push soil ahead of it. This is known as dozing, hence the name, bulldozer. Bulldozers can also be used to push and pull other equipment. This requires traction, or the ability to push something without slipping or tipping up. To provide maximum traction, bulldozers are usually mounted on tracks. In addition, the center of gravity of the bulldozer is kept as low as possible by having the engine and drive mechanism close to the ground. However, they are relatively slow and are really only economical for moving material over short distances, up to a few hundred meters. The main attachment on a bulldozer is the blade at the front. The blade is lifted and lowered by hydraulic rams, similar to the system used with excavators. During dozing, the blade scrapes up and pushes the soil in front of it. The cross-section of the blade is a flat C-section, which results in the scraped soil curling up in the blade and rolling in front of the blade. The blade can be lifted to allow some of the soil to be laid in a layer beneath the blade when the bulldozer reaches the fill area. Obviously, the amount of soil that can be pushed in front of the blade is limited, so bulldozers are really only effective when the soil needs to be moved short distances, around a few hundred meters, when dozing. Some bulldozers may be fitted with additional rams to allow them to tip the blade forward and back, a motion known as pitch, or angle it so that the push materials rolls off the side of the blade in a process known as side casting. Side casting is particularly useful when clearing topsoil, as the bulldozer can move back and forth along the area, pushing the topsoil sideways and off the area to be cleared. Bulldozers may also be fitted with rippers at the back. You can see that on this picture here, there's a three-pronged ripper at the back on the right. They consist of one or more shanks or rippers, which are lowered into the rock surface and are dragged through the rock, so breaking it up. Bulldozers can also be used to tow unpowered scrapers or rollers, or to assist powered scrapers in heavy or wet ground. So let's look at scrapers. Scrapers are specialized earth-moving equipment. They are able to cut, haul, and lay large quantities of soil in one process. Basically, a scraper scrapes up the soil in a 10 to 300 millimeter thick layer. Scraped soil is forced into the scraper's bowl. When the scraper is loaded, it lifts the bowl and travels to the fill area. At the fill area, the bowl is dropped and an ejector plate pushes the soil out of the bowl. The scraper is moving during this operation, so the soil is laid in a thin layer suitable for compaction or drying. Scrapers may be powered or towed. Powered scrapers have their own engine and can move on their own. Some also have a conveyor in the scraper bowl that allows it to move scraped soil up into the bowl. These are called elevating scrapers. Towed scrapers need to be towed by a bulldozer. So here's a picture of a towed scraper with a bulldozer. Most of the scraper is a large bowl into which the scraped soil is pushed. So you can see the bowl at the back there. There is a cutter at the front of the bowl that cuts the soil on the ground level there. The forward movement of the scraper pushes the soil up into the bowl. When the scraper is full, the bowl and cutter are lifted and the scraper travels to the fill area. The bowl is lowered slightly at the fill area and an ejector plate inside the bowl, you can't really see it in the photo, but there's one there. It pushes the soil out of the bowl as the scraper moves along the fill area, which results in the soil being laid in a long thin layer ready for wetting, drying or compaction. In addition to towing the scraper, the bulldozer also provides hydraulic pressure to lift and lower the scraper bowl and move the ejector plate. You can see the black hydraulic hoses on the front of the scraper that connect to the bulldozer's hydraulic system. Towed scrapers are slower than powered scrapers as the bulldozer runs on tracks. However, the tracks mean that the towed scraper has more traction and is better suited to cutting heavy or wet soils. In these soils, the powered scraper with its wheels would not have the traction to load the bowl. So let's look at an elevating scraper or powered scrapers. Powered scrapers have their own engine and can move on their own. So you can see the engine at the front there. They usually have wheels rather than tracks. This means they can travel faster than bulldozers with a towed scraper. They're also faster to load than trucks which have to be loaded by an excavator. They are able to lay the soil in an even layer on the fill area. Trucks normally dump the soil in a pile which has to be spread by a bulldozer. So when you're using trucks, you have to have an excavator to load them and a bulldozer to spread, whereas a scraper does all three activities by itself. All of these factors mean that a powered scraper often has a faster cycle time. So cycle time is the time it takes to load, travel, and lay the material, and then return back to loading again. So they're able to do this faster than other options when the haul distance is between 400 and 2,000 meters. For longer hauls, trucks loaded by excavators tend to be more efficient as they can travel faster. So what they lose in the loading and dumping times, they make up for in the travel time. The downside of having wheels is that they do not have as much traction as tracked vehicles. This means they may not be able to cut and load heavy or wet soils by themselves. In these types of soils, they may need the help of a bulldozer, which will push them during the loading of the material. This is called push loading. This photo shows an elevating scraper. You can see the elevator in the bowl. The elevator carries the cut soil up into the bowl. This means that all the power of the scraper is used to do the cutting rather than cutting and pushing the soil into the bowl, which is what other motorized scrapers have to do. This means that elevating scrapers are better able to cut and load heavier soils. It's worth noting that this scraper shown in the photo weighs about 100 tons when loaded. In the following videos, we will look at how this plant is used in road earthworks operations.